Okay, so as you guys saw in that nerd study video, we have a situation with ambiguous case that there are two potential triangles. So here's what I'd like you guys to do every single time that you notice or see the information that you have is potentially set up for an ambiguous case. To be an ambiguous case, what you're going to be given is you're going to be given an acute angle. You're going to be given its matching side. And you're also going to be given what I'm going to call as your other side. And how we set this up and what you saw in the video on that nerd study video is your angle was always put in that lower left corner. So that's where I want you to start. So if you notice that you are given an angle, potentially maybe angle A, and then side A, and potentially side B, or maybe you're given angle B, and side A. Whatever you have, you're going to have the angle, its matching side, and the other side, and I want you to put that angle in the lower corner. After that, what I want you guys to see is on the far side, you're going to put the matching side. And lastly, adjacent to that angle, you're going to put the other side. And that's because how that nerd study video showed you and what I'm going to do in class, that matching side is the side that swings. This is the way we set this up. If you go back to your geometry knowledge, this would be that angle side. Big gasp. This is, don't swear in class. This is why in geometry, angle side is not an option in order to prove triangles are congruent, because of the fact that we don't know which triangle it could be. Is it the acute triangle or is it the obtuse triangle when you swing that matching side closer to the angle? So here's our situation. We have 4 possible outcomes if that given angle is acute. So let's put our angle here. I'm going to put the matching side. We're going to call this side A, and I'm going to call the angle as angle A. I'm going to call the other side angle or side B. And I'm also going to add that altitude or that height in there. So first and foremost, if your matching side is less than your height, there are 0 triangles possible. If your matching side is greater than your height, but it is less than your other side, so it's kind of smack dab there in the middle, this is your perfect scenario for 2 triangles possible. Now, on the other side, if you have your matching side and it is greater than your other side given, now these A's and B's can be flipped around, but if your matching side is greater than your other side, then you don't have to necessarily look for 2 triangles. Even if you do, that second triangle won't exist. There won't be room for that third angle. I know they briefly talked about that in the video. This would be a 1 triangle possible. And lastly, if your matching side is equal to your height, this would force this to be a right triangle, and therefore only 1 right triangle is possible. And as they went and talked about in that video, for us to find that height, we're going to use this angle A in there, and we're going to do a basic SOHCAHTOA. So we would say the sine of angle A is equal to your height over that that other side B, because that would be the hypotenuse in that right triangle. We would multiply both sides by B, and we would have that equal to your height. So in essence, guys, your other side times sine of your angle is always going to be equal to your height. Now, if that given angle is obtuse, there are only two possible outcomes. So this given angle down here is obtuse. I have my matching side. I have my other side. If that angle A is obtuse, let's compare the side lengths. If side A is going to be greater than side B, there would only be one triangle possible. If your side A is less than your side B, there would be 0 triangles possible. Go back to that hinge theorem. The biggest side is across from the biggest angle. So if side A is not your biggest side, then angle A can't be your biggest angle. Therefore, angle B would have to be bigger than angle A, and that's just not possible. All right, so let's do a couple problems. With this situation, given angle B is 55 degrees, I have my acute angle, I have my matching side, and I have my other side. So let's take a look at this one. Let's set this one up. So I told you guys, always set up your picture with that given acute angle in that lower left-hand corner. So that's 55 degrees. My matching side goes across from it, 8.94. And I'm going to put side A at 25.1. Obviously, my picture is not accurate, but we'll work with it. So first and foremost, let's drop that altitude. Let's find that height. Let's do some comparison so I know how many triangles I'm even looking for in this picture. So we defined this using SOHCAHTOA, and we said that my height based on SOHCAHTOA is equal to my other side times the sine of the angle. So if I open up my calculator, and I type in there 25.1 times the sine of 55, I get my height to come out to be at 20.5. So I have a height of 20.5. And what I notice is that my matching side is less than my height, which anytime my matching side is less than my height, there are no triangles. Not possible, no solution. Now, if you guys had tried to do this and you went through your work and you said, okay, law of sines, let's do my 8.94 divided by the sine of 55 equals my 25.1 over the sine of angle B. And we did that cross multiplication, so 25.1 times the sine of 55. Divide that by 8.94. You're going to see that we get sine of angle B to come out as 2.299. Guys, that's outside of sine's range if you think about the graph. So it only makes sense that if you try to do inverse, they're going to tell you this is not possible. So even if you didn't solve for that height first, your work would get you the same answer. So let's look at one that does work. So we have the next situation. Here's my given acute angle, my matching side. Let's do that one in blue. And then I have my other side. So I'm going to set this one up. This is that angle side situation. Put my matching side in and my other side. And from here, I know that this would be called angle B. And therefore, last but not least, we've got angle C up at the top, and we'll work that here in a moment. Thinking about what my altitude would be, and I'll erase that just so my picture doesn't get too crazy here in a moment, but I do want to find what that height is. It would be my other side times the sine of 55.3. So 24.9 times the sine of 55.3. My height does come out to be 20.47. And what you're going to notice is that your matching side is greater than your height, but it is also less than your other side. It's smack dab there in the middle. So this would be a perfect two triangle situation. So when I notice that there are two triangles, what you're going to notice what I do on the side is I go and I set up my little T-chart so I know that I'm making sure that I solve these triangles in the right order and making sure I know that I have to solve for both. So the first thing that I would actually solve for is angle B. And what you're going to see and what you saw in the video is that angle B was the first triangle that was solved in both situations. So we're going to set up angle B of triangle 1 would be this angle right down here. That's what we're looking for. And I'm going to get rid of my pink height just so I have some space to work in my triangle. So I would do this like normal. I have my 24.9 over the sine of angle B is equal to my 22.8 over the sine of angle A, which was 55.3. I do my cross multiplication. $24.9 times the sine of 55.3. I would divide that by 22.8, and I would do inverse sine of that answer. I know I'm going through that fast, you guys. Please feel free to write out your cross multiplication step and do your algebra to get there. Angle B comes out as 63.88. So I go over to my T-chart and I know that that first angle would be 63.88. Now, here's what happens. If you guys remember from the video that this matching side, what they do is they say, hey, it could connect here or here. So spot 1 or spot 2. Spot 1 or spot 2. And what they said was, if I had a better picture, if this is 63.88, because of the fact that this matching side is the exact same length in both positions, this is the same as this, we've created an isosceles triangle. So this one is also 63.88. Base angles are the same in isosceles triangles, which then this angle right down here, that purple one, has to be supplementary. This purple one is angle B of triangle 2. So for me to find angle B of triangle 2, I would take 180 and I would subtract B from triangle 1, and this would get me out 116.12. This is something I want you to star, highlight, underline, do whatever you guys need to do to understand that these two angles will always be supplementary. Okay, they will always be supplementary. So at this point, I have solved for my first angle. Now I know that I can go ahead and solve for angle C that using, and the first angle C that we're going to try and find is using this bigger triangle right up there. So I know that all angles in every triangle add up to 180. So I'm going to take 180, subtract my 55.3, subtract my 63.88, and that leaves me with angle C to come out at 60.82. Well, now I can find side C of that yellow triangle by doing my law of sines. So side C over the sine of 60.82 equals 22.8 over the sine of 55.3. Do my cross multiplication. And I get side C to come out as 24.21. And that's the yellow triangle. Now I'm going to go back and let's look at the situation where we've created this smaller obtuse triangle in there using B of triangle 2. So that means my information is going to be slightly different. My answers, my angle C of triangle 2 is going to be different. I'm still going to use the idea that all angles add up to 180. So I'm going to take 180, subtract 55.3. But now I'm subtracting B of triangle 2, which was 116.12. That leaves me with a teeny tiny angle up there of 8.58. This is a C, not a G. And then I need to solve for little side C. So I would do side C over the sine of 8.58 equals my 22 point, I'm using my given information, that 22.8 over the sine of 55.3. Do my cross multiplication, 22.8 times the sine of 8.58. Divide that by the sine of 55.3, and I get out side C is 4.13. Awesome. So I have all my information, all of my angles, all of my sides for both triangles. Now let's do this very last one. I have this given acute angle. I have its matching side, and I have the other side. And right away what I notice is that my matching side is greater than my other side. Therefore, there is only one triangle. So we would set this up like we would normally do a law of sines. I don't have to look for that second triangle in there. If you did look for that second triangle, it wouldn't exist. Your math would show that. So this is 43.5. This is 10.7. This is 7.2. So to figure this one out, this is angle B. Let's go angle C and side C. Let's set up angle B first. So I would have my 10.7 over the sine of 43.5 is equal to 7.2 over the sine of angle B. Do my cross multiplication, 7.2 times 43.5. Divide that by 10.7 and inverse sine of that answer. Angle B is 27.59, so that's one of the things we need to solve for. To find angle C, take 180, subtract the angles that we know. I get angle C to come out at 108.91. And last but not least, we would do my side C. So I'd have side C over the sine of that big angle, 108.91, and that is equal to 10.7 over the sine of 43.5. Do my cross multiplication. Divide by sine of 43.5. And there's your side C, 14.7. All right, you guys, so that is your notes. You've got that nerd study video that's in Schoology that I posted. So you can also watch that as some examples. And here are 3. Your homework is going to be all of page 18 and 19. It looks like there are 6 total problems. So pages 18 and 19. Have a great day.